Hi and welcome to a tutorial over the limiting reactant. Please have out your green notes, a periodic table, and a calculator. I'm beginning on page 5 in your notes. In a chemical reaction, one of the reactants will usually run out before the other reactants. At this point, the reaction will stop because one of the reactants is used up. The reactant that's used up first is called the limiting reactant. It controls how much of the other reactants you will need, and it also controls the amount of product you can make. The other reactants is or are called excess reactants because there will be some of those left over. Here's an example with grilled cheese sandwiches. Say that you're given 10 pieces of cheese and 50 pieces of bread, and the equation for making a grilled cheese sandwich is below. So we're saying here that you need 1 piece of cheese and 2 pieces of bread, and that will create a grilled cheese sandwich. The question is, how many complete cheese sandwiches can you make? Well, in order to figure this out, you have to start with both givens. So the 10 pieces of cheese and the 50 pieces of bread. So in my first equation, I'm going to start with the 10 pieces of cheese. And what I'm going to convert to, or what I'm going to figure out, is how many grilled cheese sandwiches I can make, which is the product. So from the balanced equation, since it's going to take me 1 piece of cheese to make 1 cheese sandwich, that's a 1-to-1 ratio. So this is like the ratio step in stoichiometry. So 1 piece of cheese for every 1 sandwich. And I end up finding out that I can create 10 sandwiches. Okay, so I'm going to do the same exact thing, but I'm going to do it starting with my pieces of bread. So if I have 50 pieces of bread, the ratio is different because I need 2 pieces of bread for every 1 cheese sandwich. So the 2 pieces of bread go on the bottom for every 1 sandwich I can make. So I end up finding out if it was solely dependent on bread, I can make 25 sandwiches. This is how we discover the limiting reactant. I'm going to compare both of my reactants and see how much product they can make. The one that makes the least amount of product is my limiting reactant. So because 10 sandwiches is smaller than 25 sandwiches, the limiting reactant is actually the cheese. So I want you to think about this for a second. It's called the limiting reactant. You only have 2 choices here. It's either cheese or bread because these are our reactants. It would be very silly to choose the cheese sandwiches as a limiting reactant because it's not a reactant at all. It's a product. Okay? So by doing a little bit of math, I've discovered that I can make 10 sandwiches total with these ingredients and that the limiting reactant is going to be the cheese. So if the cheese is the limiting reactant, this automatically makes the other reactant, which is bread, the one in excess. Excess means you have extra, okay? So if I run out of cheese, but I'm still going to have extra bread. So the next question, how many pieces of the excess reactant will be used? I need you to make a correction on your notes here. Make sure it says start with the, not number of complete sandwiches, but please change that to limiting reactant and convert to the excess reactant. This is the correct way to work this problem. So now we're going to begin with the limiting reactant, which was the 10 pieces of cheese. Okay, so the ratio between cheese and the excess reactant, so if this one's limiting and this one's an excess, is 1 cheese for every 2 pieces of bread. So what I end up finding out is I'm going to use 20 pieces of bread. Okay, so that's how many will be used. 20 pieces. Now the next part of the question is going to be how many pieces of the excess will be left over. Now this one's nice. All you have to do is subtract, which makes us happy. We can all subtract. So how many pieces did I have originally of bread? If you look back, we started with 50 pieces of bread originally. I'm going to subtract how much we used, which was 20. So I end up with 30 pieces of bread that is left over. Okay, so simple subtraction will do that last part. So this is the analogy using a grilled cheese sandwich. This can also relate to a chemical reaction. Okay, so here's an example. It says aluminum reacts with copper 2 chloride to produce copper and aluminum chloride. Assume that the copper 2 chloride is the limiting reactant. Which substance or substances will be present in the reaction container once the reaction has completely stopped? So what I want you to understand is they're telling us that copper 2 chloride is the limiting reactant. So we run out of that. Everything else will be present in the reaction container. We've made product, but we also have extra or excess aluminum. So it will be present too. So the answer is aluminum, copper, and aluminum chloride. All but the limiting reactant are present. And hopefully when you look at this reaction, you can still easily classify it as a single replacement reaction. Okay. So now we're going to go a step further. We're going to apply this analogy of a grilled cheese sandwich to actual stoichiometry problems or limiting reactant problems. So pay attention, make sure you're taking good notes, and that you can follow the steps. In basic stoichiometry problems, you're provided with only one given quantity. In limiting reactant problems, you're provided with amounts of both reactants. Before you can solve the stoichiometry problem, you have to find out which of the two reactants is your limiting reactant. This is very important. The limiting reactant is used as the given quantity in all calculations because it controls the amounts of the other reactants used up, and it also controls the amount of product you can make. It is possible to have two reactants run out at the same time. If this happens, the amounts are called stoichiometric amounts. In this special case, you can use either reactant as your limiting reactant. It does not matter. Okay. So here are the steps. So how do you find the limiting reactant? If you follow these 3 steps, you should be able to do it. So start with a given amount of one of the reactants. We'll call this reactant A. And solve for the amount of one of the products. We'll call this product B. So you're starting with a reactant. You are solving for a product. Next, start with the given amount of the other reactant and solve for the same product. Make sure it's the same exact product. The reactant that produces the least amount of product is your limiting reactant. So very important that you understand whichever one produces the least is your limiting reactant. You must then use the limiting reactant to work out any additional stoichiometry problems. Let's try one. So the first thing you have to have is a balanced chemical equation. At this point, we really expect that you're good at this. So I'm going to balance my equation. And then I'm going to work my problem. So find the limiting reactant of 0.25 moles of aluminum and 0.35 moles of copper 2 chloride if they are available. So the first step told me that I needed to convert from reactants to products. So I'm going to choose one. Notice I have 2 different products here. I'm going to choose the one that looks more simple. So I'm going to choose the 3 moles of copper. And I'm going to do a mole-to-mole ratio to get me from moles of aluminum to moles of copper. So what I know is that for every 2 moles of aluminum, I have 3 moles of copper. So when I do the math, the amount of copper that's made is 0.38 moles of copper. Okay. Now I have to do the same exact thing for the other reactant in the problem, okay, because I need something to compare. So now starting with the 0.35 moles of copper 2 chloride, I'm going to do a new mole to mole ratio step between the other reactant, copper 2 chloride, in the same product. So now I have 3 moles of copper 2 chloride for every 3 moles of copper, which comes out to 0.35 moles of copper. After you've figured out how much product you can make, which is what we just did, you need to compare your two answers. So in comparing our two answers, we want to see which one is smaller. So the one that is smaller is obviously 0.35 moles of copper. What this means is our limiting reactant is our copper 2 chloride. So again, the limiting reactant is the reactant that produces the least amount of product. Which one's the least amount of product? The 0.35 moles of copper. Okay, so that's an easy example. I want to go through the next example as well, which is a bit more challenging because it has all the steps we would be asking you to solve in a limiting reactant problem. Okay, so now we're on to number 18. It says find the limiting reactant if 6.20 grams of aluminum and 48.5 grams of copper 2 chloride are available. Okay, so notice this time we are starting with grams instead of just moles. So you have to be very good at doing stoichiometry to solve these. So I'm going to write down my 3 steps of stoichiometry just so I don't forget. Remember, step 1 is to take your given and convert it into moles. Step 2 is that mole to mole ratio step coming from the balanced chemical equation. And step 3 is to convert to the correct unit. Okay, so that's exactly what I'm going to do. I'm going to start with my first reactant, 6.20 grams. I'm going to first convert it to moles. Well, going from grams to moles, you use the molar mass. So looking at a periodic table, the molar mass is 26.982 grams of aluminum for every 1 mole of aluminum. Okay, so that is step 1. Step 2 is my mole to mole ratio step. So I'm going from moles of aluminum, which is 2 moles, to a product. So I'm going to choose that same product, copper. Okay. Please know that when you're figuring out your limiting reactant, it is okay to stop here. You can stop after the ratio step if you want. If you want to go all the way to grams, that's okay too. But it is okay to stop after the ratio step. So 6.2 times 3 divided by 26.982 divided by 2 gives me in my calculator, rounding to 3 sig figs, 0.345 moles of copper. I'm going to do the same thing, but starting with the other reactant, which is copper 2 chloride. Okay, so again, I'm going to let you know you can stop at the ratio step when determining your limiting reactant. Okay, so I need to go grams to moles, which means I need to calculate the molar mass of copper 2 chloride. It comes out to 134.452 grams of copper 2 chloride for every 1 mole of copper 2 chloride. Okay, so step 1 is done. Next, I need the ratio. So for every 3 moles of copper 2 chloride, I have 3 moles of copper. So I'm solving for that product, putting it in my calculator, 48.5 divided by 134.452. Ooh, my calculator is having a problem here. Okay, I get 0.361. 0.361 moles of copper. Okay, so again, once you've done this step, you want to compare your two products. So I'm looking at my products, and this one is less. So that means aluminum is my limiting reactant. Okay, this is very important. Once you've determined your limiting reactant, then that reactant becomes the given for all of your other problems. So the 6.20 grams of aluminum will now be my given for B and C. So I go ahead and I just write it in for those next two parts. So I know to start with it. Okay. So what is part B asking? How many grams of copper will be produced? Okay, so I'm starting with my limiting reactant, and notice it's saying grams of copper. So I need to go through all the steps of stoichiometry. One is going to be converting to moles. So using the molar mass of aluminum, which is 26.982 grams per 1 mole of aluminum, I've done that first step. Step 2 is the ratio step. Again, you're looking at that balanced chemical equation. For every 2 moles of aluminum, I have 3 moles of copper. Okay, and then I do need to do that last step here to convert to the correct unit, because here it's asking me specifically for grams of copper. So for every 1 mole of copper, I have 63.546 grams of copper. That's just coming from the periodic table. Multiplying across the top, dividing by the bottom, rounding to 3 sig figs, I get 21.9 grams of copper. And that is my final answer. Okay, then for part C, how many grams of the excess reactant will be used? Okay, so again, we're going to start with our limiting reactant. I want to emphasize that if aluminum is our limiting reactant, then the other reactant is the one in excess. Okay, so it doesn't tell me in the problem to convert to copper 2 chloride. I actually have to know. All right, so we're going to go through the same 3 steps that we're very familiar with. First, convert to moles. So 26.982 grams of aluminum for every 1 mole of aluminum. Step 1 is done. Step 2 is a ratio. Now the ratio is going to be different because it's going to be between the limiting and the excess reactant. So 2 moles of aluminum for every 3 moles of copper 2 chloride. And notice it's asking for grams of the excess. So I need that last step converting to the correct unit, which is grams. So for every 1 mole of copper 2 chloride, I've done the math already. The mass of copper 2 chloride is 134.452 grams. And solving, rounding to the 3 sig figs, I get 46.3 grams of copper 2 chloride. Okay. Then there's one last part that I can ask you. I know it's a lot, but the one last thing is how many grams are left over. So what you have to do is simple subtraction, just like with the cheese sandwiches. We started with 48.5 grams from part A of our copper 2 chloride. So this is what we started with. Okay, I'm going to subtract how much I just used, which is what I just figured out. So the 46.3 grams of copper 2 chloride used, and that'll give me what I have left over. And what I find out is I have 2.2 grams that are left over. Okay, I hope this tutorial helped you. Please feel free to watch it again if you need to. Stoichiometry and limiting reactant are challenging, so make sure to practice. There's plenty of work in your practice packet. Have a good evening.